Welcome to my presentation. My presentation is on stock market prediction, predicting the price of stocks, and using ensemble of, that means multiple methods of graph theory, machine learning, and deep learning models. So you can see it's our predicting stock market price, and we are using a deep neural network. However, we'll be also using graph theory. So this is side. Now, what is the problem? The efficient market hypothesis, right? It tells that at any moment, a stock price resembles fair market value considering all the different variables. And you cannot consistently beat stock market price, stock price. That's the efficient hypothesis, and many models are work on it. Okay. Now, opponents of efficient market hypothesis, they tell stock markets don't always represent the fair value. Sometimes they deviate, and it is possible to beat the market. Maybe both are correct. You cannot beat consistently, but you probably can beat sometimes, right? So we predict stocks, right? What we usually do, I think the investor managers, they select proper selection of stocks and some time separated for time interval, and then they try to beat the market. So what they use, usually statistics, they use statistics to understand the pattern and predict, and then also machine learning, right? Now, what is different about this paper? So the machine learning and statistics that used to use, they use just data, right? Data, but they don't represent it in the graph format. But this paper, they use the graph. They represented everything into graph, and then they applied their model onto the graph. Now, what else this does? This also captures the spatio-temporal relationships among the stocks. It means that at a different time, how those stocks are interrelated or related to each other, moving prices each other, that it also captures those, the relation spatial space that is put into the graph. Now, they're using graph, right? So what is the output? Yeah, in general, yes, graph gave better result, better prediction results than the other methods. They are saying that because they are using this structural information, how stocks are related to each other, represented in the graph, that's what helped them to achieve a better stock market prediction. And how they did it? They created two different types of graphs. One thing is correlation-based graph, correlation among the different stocks. That is one type of graph. And another type of graph, causation-based graph. What did they use for it? The financial news mentions of those different stocks, they created a graph out of it. It means that if two stocks are discussed in the same article, that means they are related, and they put some sort of edge in between. We'll see more on this. So this is how the different types of graphs that are constructed. You can see the first one is the Pearson correlation between different stocks, historical price movement stocks, right? Historical price movement, and the Spearman and the Kendall-Tau coefficient. And the last one is the news co-mentions. As I told, if they mention the same article, they will be considering billions of news articles to create this graph. And Spearman and Kendall, they can capture the non-linear relationships among the stocks. That's how they usually perform better than the Pearson. So some more details on how stocks are being modeled into graph. I already told stocks, they will represent the node of the graph, and then whether there will be an edge or not, that the correlation will determine that, right? Pearson correlation, Spearman, and Kendall-Tau, all three of them create three different graphs, A, B, and C. And then the fourth one, graph D, that is the position financial news. If stocks are mentioned, then we are creating edges, and for each paper article mention of them, we increase the weight of that particular edge. That's how we get the. Yeah, I already told, right? Depending on the correlation thing, they use some sort of threshold, right? If for Pearson correlation, if the threshold is 0.5 Pearson correlation, and for Kendall and Spearman, they use slightly lower, probably 0.4 and 0.3 threshold because they capture the nonlinear. So that's and they usually perform better. As I told, for each news article, they increase the weight. Now, how this overall thing works, right? Let's say we have the graph neural network, a convolutional neural network, graph-based convolution neural network. Now, we are feeding the graph structure. We are feeding the graph structure into the deep neural network, and we are also feeding the feature, right? The first one, that is the adjacency matrix for the graph structure matrix, and the second one, X, that is the matrix of features for each individual stocks or nodes. Actually, they capture different types of 30 different features and they put it there and then feed it, right? And then after this transformation and convolution, eventually they use a multi-layer perceptron at the end and they predict the stock prices as a one-dimensional output vector array. And this is a regression problem. So why they have used graph, or how they use the graph, right? Usually other papers, they use some other methods like LSTM, RNN, or model one stock at a time. What this paper did differently is it considered relations among the stocks, repeating, and they also build CNN-based deep neural network. That's one thing, right? A deep neural network, they used it and predicted the stock market prices. They actually used another machine learning based network, and they predicted the stock market prices. In both cases, they supplied the graph. One is using deep neural network and another is using machine learning based network and linear regression. Okay, this is a little bit more on the deep learning convolutional neural network. You can see graph structure is using, and there are multiple blocks of CNN and graph convolutional network. Seeing the transformation, feature extraction, everything happens, and then at the end we predict the stock market price, and spatio-temporal features are being recorded or captured, right? Now, for the linear model, right? For the linear model, what did they do? They divided the stocks into clusters, and for each cluster, they took one stocks and then created the graph among those stocks, and then they feed into the linear model and predicted the price. Their idea is the representative prediction will work for that particular group. Validated output is one-dimensional array. Now, before I show you the performance, right? Before I show you the performance, I think let's compare the performance first, right? Because we saw that there are different things that we did, different types of graphs that we constructed like causation-based financial news. I think Pearson, Spearman, and Kendall. Now, which one performed better? Okay, actually, we'll see, but I think I'm just saying that the graph-based causation graph that performed the best in general, and then Kendall-Tau correlation, the nonlinear graph convolutional network that worked the second best, and then third best is the Spearman, and then the Pearson, and then the traditional statistical method that performed the list. Now let's see some of the prediction results. So it's 3 time steps ahead. They did it for 3 time steps, or 6 time steps, or 9 time steps. They didn't specifically mention whether time step means days or months, but I think you probably can configure it that way. I think in general it will be days because that's what they did in general. Okay, so let's say, so we can say, let's say RMSE, root mean square error. I think the less is better, right? So position, you can see that it is the lowest. Then candle tau a little bit higher. And for this Pearson and Spearman, it looks like Pearson probably did a little bit better than the Spearman as far as I can see. And minimum average performance error, right? Minimum average performance error. So in that case, it's still, I believe candle perform better than the cohesion, than Spearman, than this. And minimum average error, okay, it looks like yes, cohesion and candle worked better, and then the Spearman, and then the Pearson, right? So yeah, I think this is the slide there. It probably will be very similar. I don't need to explain much because it's out of time. What are the limitations of this work? I think this work faces the limitation that exploding gradient problem. That means the node with higher degrees will have higher feature representation, higher values of feature representation in the convolutional network. Lower one will have lower, that probably can bias the result, right? Or it also creates the exploding gradient problem. I think gradient over the time becomes very large. So that is a problem. I think in general, it's a machine learning problem that this work shows. So what can be the feature work? Yeah, definitely resolving a gradient problem. It will make the training faster and better. And also, they used only 30 node scribe. This can be applied on the bigger graphs. And also, this concept can be used in a generic time series forecasting problem. In that way, things can get better. The output, I think we can make use of this work and get something out of it. Okay, thank you very much. This is my references. Okay, if you have any questions, feel free to ask. Thank you. Have a good day. Bye.